the students out there. My name is Jonathan Kamulegeya. Today we're going to have a continuation of our video we had last time. And today we are going to look at practice problems of balancing chemical equations. That's what we're going to look at basically. We're going to do more numbers of balancing equation so that we can learn and see how we can balance. Okay, let's start with the first example. It's going to be Zn plus fluorine giving us okay, we need to balance this equation here, and I will say that in balancing chemical equation, our main concern is to make sure that the number of reactants is the same as the number of products of each type of atom present. In this case, we have the Zn, and also we have fluorine. Also this side we have the Zn, and so we have the fluorine. In this case, we have one Zn here, what is 1, and also fluorine, it is F2, we have 2 atoms. And so here we have 1 of that, so here we have 6. Our main concern is to balance. We need to learn to see we can put the number so we can balance this thing. Since here we have 6 fluorine, if I put a 3 here, meaning that 3 times 2 to make us 6, meaning this one changes to 6. Since this one is 1, that's 1, this is 6, that's 6. Meaning that that equation is balanced. By writing Zn1, 3 fluorine, put a 1 here, meaning that our equation is balanced. Is it okay? Yes, that's our first example. Let me hope we are together, my dear students. My second example is going to be, if I get my silver plus hydrogen sulfide, it's going to give me silver sulfide plus hydrogen. I need to balance this equation to see. We say that we start by writing atoms on both sides. Here we have silver, we have hydrogen, so we have sulfur. The same thing here, we have silver, we have hydrogen, we have sulfur. We have one silver this side, we have 2 hydrogens, and we have 1 sulfur. This side we have 2 silvers, we have 2 hydrogens, and we have 1 sulfur. We need to start to balance our equation. We were saying that silver is not balancing, hydrogen is balancing, sulfur is balanced. We're going to start by balancing silver. In this case, we shall multiply by 2 here. Multiply by 2, 2 times 1, you get a 2. This one changes to a 2. Meaning that 2 silvers, 2 hydrogens, 1 sulfur, 1 sulfur. My equation is balanced in this case. Okay, let me hope we are together. In that case, let's go to another example. We can rub off. Another example, we have potassium hydroxide plus carbon dioxide, potassium carbonate plus water. Okay, in this case, we need to write the elements present on both sides. We have potassium on this side, we have oxygen, we have hydrogen, and we have carbon. Potassium, oxygen, hydrogen, carbon. This side we have the same elements. It is potassium, oxygen, hydrogen, and the carbon. Now in this case, we have one potassium here. We have oxygens, we have 1, plus 2. Because here we have 2, it has to be 1 plus 2, which is 3 oxygens. Hydrogens, we have 1, and carbon, we have 1. This side, we have potassium, it is K2, meaning that we have 2 potassiums. And also, oxygen is 3 plus 1, makes it 4. 4 oxygens. Hydrogens, we have 2. 2. And carbon, we have 1. Is it okay? Let's see. The potassium is 1. The carbon is, the potassium here is 2. The oxygen here is 3. Plus the oxygen here it is 4. The hydrogen it is 1. Plus here the hydrogen it is 2. The carbon here it is 2. It is 1. Plus here the carbon it is 1. Meaning that we need to get ways we can balance our equation, and we see how we can make it balanced. Take an example. If I decide to put a 2 here, if I put a 2 there, meaning that this 2 times 1, this becomes 2. We have 2 potassium there. A 2 times 2, 2 times 1, that's 2, plus 2, that's 4. Meaning that the oxygen becomes a 4. And also, a 2 times a 1 gives us a 2. This one becomes what? A 2. Carbon stays 1. Meaning we have 2 potassiums, 2 potassiums. 4 oxygens, 4 oxygens. 2 hydrogens, 2 hydrogens. 1 carbon, 1 carbon. The equation is balanced. We have made sure that the number of each atom is same. Is the same as the number of each atom the other side. If nothing has happened, then our equation is a balanced equation. Is it okay? Alright. Let's do another example. You put down that very fast. And you do another example and you see how we can balance it. Another example we can put here is going to be a sodium plus chlorine is going to be sodium chloride. We want to learn how we can balance that one. Now let's write the elements of each atom on both sides. Sodium, have sodium there, and we have Cl. Inside also we have sodium and Cl. Now, sodium it is 1. Cl it is 2. Whereas sodium here it is 1, and here Cl it is 1 also. We need to balance it out and see how we can balance it. If I put a 2 here, this one 2 times 1, this one goes to 2, and 2 times 1 is goes to what? The 2. Meaning that chlorine is balancing, but sodium here it is 2, sodium here it is 1. Sodium now is not balanced. What I do, I change, I put a 2 here. If I put a 2 here, it's going to multiply to give us a 2. Meaning that now sodium, there are 2 sodiums, 2 HCl's, 2 HCl's. My equation is a balanced equation. Is it okay, my dear students? Okay, we put that one down. Another one we can put. We can do this one here. Iron oxide plus carbon. It's going to give us iron plus carbon dioxide. Plus carbon dioxide. When you look at this equation here, you need to first list the elements on both sides. We have iron, we have oxygen, and so we have carbon. This same side also we have iron, we have carbon, also we have oxygen and carbon. We'll write them in the order. If you look here, we have 1 iron, we have 1 oxygen, so we have 1 carbon. Is it okay? Also here, we have 1 iron, we have 1 carbon, We have 2 oxygens and also 1 carbon. Iron is 1, iron is balancing. Oxygen, this is 1, whereas this one is 2. Oxygen is not balancing. Carbon, it is 1, and carbon, it is 1. Carbon is balanced. Now, my dear students, if I can ask you, why should I have a figure so that I can balance this equation? Yes, you have guessed right. We should put a 2 in the front here. If this is a 2, 2 times 1, this goes to a 2. Is it okay? A 2 times a 1 here, because here we have 1 for iron and 1 for oxygen. The number which is in front here multiplies each and everything in the formula. A 2 times 1 here for oxygen gives us a 2. This goes to a 2. Let's see now. We have 2 ions, whereas here we have 1 iron. Iron is not balanced. We have 2 oxygens, we have 2 oxygen. Oxygen is balanced. We have 1 carbon, 1 carbon. Carbon is balanced. What can I do so that I can balance also iron? Yes. What can I do? What I'm going to do is, I'm going to add a 2 here. If I add a 2 there, this 2 multiplies 1 here, gives us a 2. It gives us a 2. We have 2 ions, we have 2 ions, we have 2 oxygens, we have 2 oxygens, 1 carbon, 1 carbon. Meaning that my equation is balanced. By doing this, I've balanced my equation. Are you together, my dear students? Okay, let's do my example and you get to understand how this whole thing works out. Let me hope you are copying down the work. Let's copy down very fast so that we can do another example. We can rub off this part. Another example. We have such equation, we want us to balance it. We say that our first step is to list down each atom on both sides of the equation. The side of the reactants we have the silicate, we have oxygen, and we have carbon. It happens in the same side here, Si, oxygen, and the carbon. Now in this case here, we have 1 of that, we have 2 of oxygen, and 1 of carbon. The same side here we have 1, since it is Si1, oxygen, it is 1, and also carbon, 1 plus 1, that's 2. We have 2 carbons. We have 2 carbons in that case. Is it okay? 2 carbons in that case. Now we need to balance. We need to think where you should put a number so that we can balance this equation. Is it clear, my dear students? What if I put a 2 here on carbon? Because since I have 2, let me see how can I start. If I put a 2 here, if I put a 2 there, meaning that here I'm going to have 2 times 1, that's 2, plus 1, giving 3. This one goes to 3 carbons. 2 times 1, that's 2. This goes to what? To 2 oxygens. Are you saying that? Meaning that oxygen is balancing, tin is balancing, silicon is balancing, and also, but carbon is not balancing because carbon here is C1, plus it is C3. Since it is C3 here and here it is 1, I put a 3 here. If I put a 3 there, meaning that 3 times 1 takes this to 3. This thing is going to cause my equation to balance. If you look here very critically, you are seeing Si it is 1, Si it is 1 this side, O it is 2, O it is 2 this side, and C it is 3, C it is 3. By doing that, my equation is balanced. It's a simple concept. Just playing cards. You think of a number, you put a number there, and you change. But you have to think in a professional way. Is it okay? Right. Example. That's another example. It has more elements, which is more complex than this one here. If I have iron, chloride, Fe plus sodium hydroxide, giving us iron, okay, they want me to balance such an equation to say, make sure that it's a balanced equation. I have iron chloride mixing sodium hydroxide, giving me sodium hydroxide plus sodium chloride. I will start by writing elements of each on both sides of the equation. In this case, we have iron here, we have Cl there, we have sodium there, we have oxygen, and we have hydrogen. The same elements, they appear also on this side. We have iron, we have Cl, we have sodium, and so we have oxygen, and we have hydrogen. In this case, we have one iron, it is 1. We have 3 Cl, we have 1 sodium, we have 1 oxygen, we have 1 hydrogen. Is it okay? Also this side here, we have 1 iron, but remember here we have a bracket. This bracket means that this 3 multiplies each and everything in the bracket. That's what it means. This bracket means that the 3 outside here multiplies each and everything in the bracket, implying that the 3 times 1, 3 oxygens, meaning that here we have 3 oxygens, 3 times 1, there are 3 hydrogens, we have 3 hydrogens, sodium, which is 1, and Cl, which is 1. In this case, you are seeing that iron is balancing, Cl is not balancing, sodium is balancing, oxygen is not balancing, hydrogen is not balancing. We need to think of a number which we can use to balance. If I start by putting a 3 here, a 3 there, you are seeing that sodium, 3 times 1 is going to become 3 sodium. This goes to 3 sodiums. 3 times 1 goes to 3 oxygens, goes to 3 oxygens. 3 times 1 goes to 3 hydrogens, this goes to 3. Meaning that iron is balancing, chlorine is not balancing, sodium is not balancing, oxygen is balancing, hydrogen is balancing. I need to think of another number which I should place somewhere so that it can balance. If you look here, if sodium here is 3, and here it is 1. If I put a 3 here, meaning that 3 times 1 here will take the sodium to 3. 3 times 1 here will take my Cl to 3. By doing that, my equation is balanced. Reason being, I will have 1 iron, 3 Cl's, 1 sodium, 3 sodium, 3 oxygen, and also 3 hydrogen, Therefore, my equation is balanced. That's how we have balanced this chemical equation. Is it okay? Let me hope we are still together, students out there. If you have not understood, you can pause the video and rewind so that you can understand this concept. Let's put another example there and get to know how you can further understand how to balance chemical equations. That example is going to be aluminium plus sulfuric acid. It's going to give us aluminium sulfate aluminium plus sulfuric acid, giving us aluminum sulfate plus hydrogen. As we said, our starting point is to write the number of the atoms present on both sides of the equation. In this case, we have aluminium, we have the hydrogen, we have the sulfur, we have the oxygen. Aluminium, hydrogen, sulfur, and oxygen. Implying that this side also, we're going to have the same elements. We have aluminium, we have hydrogen, we have sulfur, and this oxygen. Implying that we need to write down the presence. Aluminium, it is 1. Hydrogen, it is 2 because H2. Sulfur, it is 1. And oxygen, it is 4 because it is O4. So like this side, aluminium is 2. Now, we say that this bracket here, the number outside here, multiplies each and everything with the bracket, meaning that here, 3 times 1, you get 3 sulfur. 3 times 4, you get 12.